Secretary was good enough with the life sciences to make a significant contribution of $10 million. And we're working on something now with Raytheon that I'm hearing is very close.
Very
the Secretary
close.
may ask you privately.
That's right, very close. We got good.
But it's a fabulous research building, and among other things, it helps us attract high-quality faculty members. I mean, we've attracted faculty members that are coming in with significant research portfolios, and that's one of the things we're trying to do here is drive research as a state's public research university. It's important that we keep that up, and this building is important in that. It's a great collaboration. I'll let Julie get into the details, but great collaboration with business and industry, as the Secretary knows, and that's always been Lowell's history. Lowell, really right from the beginning, the Lowell Textile School was formed to help the textile industry here and educate folks that are in the textile industry. We've always had a connection with manufacturing, and Julie will tell you about our National Science Foundation Nano Manufacturing Center, how that contributed to this building. But I think you'll be impressed by what we're doing on the technology side and the research side. So Julie, I will stop. And
No, that's a perfect intro. One actually, right? And so they're using the space and actually to make prototypes that they can use to test. And again, that's a sensor type prototype with electronics that are put down at micro scale. And the clean room allows you to do that without having contaminants that are going to make the device So I'd like to introduce, actually, we've got two of our students, Jared and Peter.
Hey, how are you? Joe. Hey, nice to meet you.
Nice to see you.
Jared, so Jared and Peter are both what we call DSMS students. They were here as undergrads, and they're doing basically one more year and a half.
Gonna be fun. All this tubing goes where
With different properties.
exactly. So many different materials are newly created, and so many exist from the past. So
How long have you had your mission?
Long time, and it's international coordination. When folks get together in the industry, let's say in Germany, we'll go to that. There'll be 300 of our alums there. We'll do a major launch. I mean, this is something that nationally is going to happen for 10 years for a long while.
Well, the commercial use of plastics has actually started in Massachusetts about 100 years ago. And so that's here in the Merrimack Valley and
Leominster.
It was the plastics capital of the world. We were the first people to put plastic cones and airbrushes and all that stuff. So we have all this modern technology, but we're building on 100 years of tradition.
absolutely, this building really changed the way we do research. We've got, state-of-the-art machines that you really can't find anywhere else. We have students from other universities that are working with our university that come here to use equipment because they just don't have it here.
So what's the thing behind you?
So this is an injection molding machine. It's got a full robot integration in it. So what we're making is these thin wall medical caps. They go they look similar to like the top of an Axe hair gel container, but they can pretty much fit on anything. Yes.
So would that be designed on a different machine? This machine, in theory,
Exactly. We've got some on the floor. We've got more in the other building. Generally, what you'll do is you'll model the part first. So you'll have the idea for the part, the model, and then in a three-dimensional simulation software, you can break this down and create for the cavity in a steel simulation. I think that's fair. Yeah. Oh yeah. That's the NC machine.
So what are you doing?
For this one, this one was actually donated to us, so we're going to be running a research study. Peter, if you actually want to talk about this, is his research is on some of